a lot of times when you're given a complex number, a real part and an imaginary part, we want to describe them differently. And one way is to describe it in terms of angles and lengths, magnitudes. So magnitudes to 0. So let's think this through. So let's say that you are at the origin, 0, 0, and x is the real part, but y is not the real part. It's the imaginary part. Well, the imaginary part is just I times whatever your value y is. And your real part is just x. So the complex is x plus yi. And when you see ABS, or when you see MOD, what we're looking at is the magnitude of this line. It's not hard. This is like super easy. All you need to know is what x is and what yi is. Because if you take x squared plus y squared, you'll get what we call r, the mod or the magnitude of that vector, if you want to call it that. So for like this one here, z is equal to -3 plus I. We know that x is equal to -3. What's y? Just 1. Don't put an I in there. It's y times I, so it's just 1. So r is just going to be the square root of 9 plus 1, or the square root of 10. That's all it is. How about for this w? What's the r going to be for w? -1 squared plus -1 squared, which will be the square root of what? 2. Yep. Okay. So here's what all I want to show you is that the properties of mods are not very friendly toward multiplication and division. Here's what I mean. What if I took the mod of this z and the mod of w? What is the square root of 2 times the square root of 10? What is that? Square root of what? 20. Good. Now, I'm going to multiply -3 plus I times -1 minus I. I'm going to FOIL this out. -3 times -1 is 3. I plus 3I is positive 2I. And what's I times -I? Careful. 1, right? Because it's -I squared, and I squared is -1, making this 1. So this is going to be 4 plus 2I. Do you agree with that? So if I took the mod of this product, 4 squared plus 2 squared, what do you get? 16 square root of 20. That's pretty cool. What if I added these? What if I added these? So I'm going to go z plus w. -3 plus -1 is 4. I minus I is what? 0I. Yep. So what's the magnitude or the modulus of this? 4 squared plus 0 squared is square root of 16, which is 4. Now, is the square root of 2 plus the square root of 10 equal to 4? No. So what we're saying here is the adding and subtracting doesn't work to add the modulus. You can't say that R1 plus R2 equals R of the total. Well, we would just say this way, like that. Same thing with subtraction. It's not the subtraction of those. I should say the total of the adding of those. We call it Z1 plus Z2. Okay, those don't add up. They don't subtract. But do they multiply? Yeah, they do. The multiplication does work. And then I just want to tell you a little bit about this thing, Z star. Z, let's say Z is 3 plus 2i. Do you know what Z star is? Take a wild guess. Three minus 2i. It's the conjugate. Just want to give you that little notation. And do you think that 3 squared plus 2 squared, is that equal to square root? Is that the same as 3 squared plus negative 2 squared square root? Will the modulus of this one be equal to of Z? Is that equal to the modulus of Z star? Yeah, those are equal. You got it. Okay, so that's the modulus. It's just the square root of x squared plus y squared. This is the formula right here. Now, that's the easy one. The icky one is the angle. But we can do it. You're going to take if this is y and this is x, what relationship does theta, y, and x have? No, not sine. Tangent, right? Opposite over adjacent. So if you want to know the angle theta, or we call the argument is the angle, modulus is the magnitude, you take the inverse tangent of y over x. Oh, I wish it was that simple. But it's not. All of the angles that we're going to have are going to be between negative pi and pi. Why? Because they made it up. It's just what they've decided the norm to be. So when we figure out what an argument is, it's going to depend on some things. But essentially what you do first, blanket move, inverse tangent of y over x. Do that first. So let's try it. Let's take, I want an easy one. Let's say z is equal to 2 plus 3i. That's a good one. And here's my x, and here's my y. But when I take the inverse tangent of y over x, that's going to be the inverse tangent of 3 over 2. Will I get an answer? Sure, you'll get an answer. You'll get an angle, and you can leave it in radians or degrees. I like to leave it in degrees. So would you take your calculators, go inverse tangent of 3 over 2, give me the degree answer for that, and then I'll tell you how we deal with that. 56.3. Now, if you want to change it into radians, I would just do this. Multiply by pi over 180. So do that. Take that answer times pi and divide it by 180. And you could change that. I think this is the best way to get these answers as opposed to leaving it in radians and you don't have a clue of what your answer means. I like to go 56.3 degrees, then multiply by pi over 180, and now it's going to be in radians. By the way, what is that in radians? It should be a little less than 1. 983. Perfect. So that's what my theta is in radians, and this is what it was in degrees. And like I said before, oh, how I wish it was that simple, but it isn't. And going quickly here, in quadrant 1, all you do is the inverse tangent of y over x. In quadrant 4, that's all you do, inverse tangent of y over x. But unfortunately, in quadrant 2, you're going to have to do the inverse tangent of y over x, and you're going to have to add pi. in quadrant 3, you're going to take the inverse tangent of y over x, and you're going to subtract pi. Do you remember doing that 2 years ago? A little bit. And then you're going to, for complex form, all that happens is x is the cosine of theta, and y is the sine of theta. If this is 1, if this is r, you just go r sine theta, r cosine theta. So I apologize, we're kind of moving a little fast here. So z is going to be r cosine theta plus ri sine theta. And this will be r cosine theta plus I sine theta, which is the shortcut r cis theta, which is polar form. We'll do more with that tomorrow. Here's what I'd like you to do for tomorrow. Do 14 and 16, just those first 2 slides. That's it. And then you have your benchmark.